Hi, today I'm gonna make a quick introduction about dynamic inside of Houdini. So don't worry, it's not that difficult. Like at high school when you study physics, your teacher tell you that every object experience some motion, which is the result of different force acting on the object. Dynamics is the study of the force which are responsible for this motion. Dynamic means powers. Here we are not learning aerodynamic, analytic dynamic. There are many dynamic. We are focusing on fluid dynamic, like when you watch a movie you can see explosion. Now the first thing that you have to know, it's a collision between objects. So I just set up a grid in my scene. I'm gonna bring here an object in the space, of course. Okay, I'm gonna control click on my sphere to bring it in the center. So at first let me delete the grid because it's interesting to see what will happen. Okay, we have our sphere here. If I want to make a basic animation, so like you see in 3D animation, they make it traditionally by hand. If I want to make it in the computer, like I want the computer to think and make the animation. But at first let's see how they do it traditionally. You have to come here. I'm gonna bring up these guys here and set a keyframe, okay, for the position. And I'm gonna come here in 7.2 and bring these guys down, this one, but let me bring it here. But you see that it's passing through. This is how you can animate it by your hands of this guy. You see, you bring it here and you put it here. Let's say that I want the computer to make it for me. Inside of Houdini, you have your dynamic strikes. When you use dynamic network to create simulation, you create object and apply one or more solvers to the objects. Houdini has a solver for many different type of simulations, such as clothes, rigid bodies, wires, and fluids. There are also specialist solver for integrating dynamics with other parts of Houdini, such as script solver, geometry solver, particle solver, and Python solver. I select my sphere object and I'm gonna come in the RVB, that's rigid body, and I'm gonna select a rigid body. It's if you choose this tool, it creates a new dynamic object and attach the subdata required for it to be properly confirming RVD object. RVD object means that it's rigid. It's rigid. It's like a metallic thing. If someone kick you with a metallic, know that it hurts than someone kicking you with just a club. Let me attach a RVD object to our sphere. You see we have an autodop network here. The autodop network, like I said before, is just creating for us it's a dynamic setup. It's a single simulation object wired to a solver. So it wired our objects here. It's wired to a solver. Let's dive inside of it. Let me bring these guys here because we don't need them. Okay, yeah. Okay, we have our sphere. It's merged. Don't worry about this merge. We are not working on them now. After that, I will explain to you in next tutorial how you can use this merge in your work. So let me play and see how it works. This is really fast. This is how the computer works, and it's not real time playing back. So our footage, it's like when we are shooting, we shoot at 24 frames per second. We have 240 frames, mean that we have 10 seconds, but the computer are playing fast. Let me check here real time playback. And you may ask yourself why it's passing through. Yeah, this is a good question. And the second question is that how this first is going down without any traditional animation, without touching him. Something cool we all love. Gravity. Look at this. Oh my god. Look. Yeah. It's just gravity. But I think that Albert Einstein, by saying that gravity doesn't have any force. It have a force, but I'm agree with Newton who said that gravity has a force. Yeah, I think that Newton is smart than Albert Einstein. Don't beat me, please. The theory of Newton is simple. I think that you learn it on high school or in college. The law of universal gravitation, which postulates that gravity causes a force where two bodies of mass are directly drawn or attracted to each other according to a mathematical relationship where the attractive force is proportional to the product of their mass and inversely proportional to the square of distance between them. So this considers to occur over an infinite range such that all bodies with mass in the universe are drawn to each other no matter how far they are apart. Wow, I like Newton. Okay, here the gravity are bringing our first object down. It's because we all know planes are stay there, are solid, they are static like the earth. Talking about gravity is really cool. Like imagine that the gravity is making the earth and the other planets orbit around the sun. You understand now how the gravity is important. If you remember at middle school or high school, your teacher tell you the amount of gravity in our world. I would break this operation here. What I wanna do is block this falling here because it's a flaw. It's not realistic that this guy is passed through this guy. Okay, if someone is more stronger than you beat him, but he will be static and you will bounce. So what I'm gonna do here, I'm gonna select my grid and add then rigid body tags on it. So I'm gonna add a static body object and let's check what's happened after that. Whoa, gravity. And you see how it's come down, but you can see that this one it's like it's have some glue or something. He come down and stay in our ground. I don't like how he come here to change these settings off. I have to use this one. So one of my teachers tell me that you already know somebody by watching how you organize his notes. Okay. Okay, let's dive inside auto the network here. Oh, look at this. It's like my room. I'm confused now. Okay, don't worry. I just resolve it. I have some shortcut for this. Okay, you just press your LK on your computer and he brings it. And now I want my ball to be reversed like a football. Okay, what can I do to make it happen? And already the computer save our life because it has cool things here. I'm gonna select my sphere object. By the way, when you look in our node tree, you can see that these guys are not wired to the same solvers because this is a static object and this is a rigid body object. Okay, and we merge them together, and this is where the magic comes. It's gravity, just gravity, and you see here. And this is our force. We have a normal gravity of 9. Okay, here I'm gonna select my sphere object and add some velocity in the Z so it can come this way. I'm gonna add it here. Yeah, this is much better. I'm gonna come in my physical attribute here, so don't mind the glue and the collision. I will explain this to you. In our bounce is at 0.5 now, Let me bring up this guys to 1. Okay, so you see that this changed to orange. It means that I have to update my, you see it bounce. Let me add like 1.6. Come back, and yeah, okay, this is much better. We are going to put our friction to the default value. Okay, it's bounce, it's collide, it's our rigid body here at dense the bounce. Okay, when we add a bounce, so let me add a velocity to this one. Okay, this will be our last step because this is just an introduction. And let me come to our initial set and add a velocity. It's like when you kick a football. Okay, let me come here and add something really big like 12. Okay, and let's watch it. You see, let me zoom this guy. I don't know where is it. Okay, we have, because we add some velocity at it. Let me bring down at 6. Okay, now that I see 12, I know that the normal velocity for this will be something like 2.5 or 3, but I'm just guessing. You see, at 6 it's come down. This is like you take your cartoony character you want to, you know, because cartoony character can make some amazing movement, and you will just use this type of animation. You don't have to spend 1 week to make only this type of animation traditionally. Okay, so let me bring these guys to 2.5. Okay, let's watch. Like you see, yeah, I like this. So to want it to fall, but it's just, yeah. So yeah, this is really good. You see how you make it. So this is your introduction to dynamics and gravity. I hope that you enjoyed this tutorial. It's just a basic one. It's not something really that's a good stuff that you want to watch. It just, I know it's boring. So by using this type of solvers, you know, you can make an ocean, you can make a lava. So it's not that boring, you know. It's step by step work, so you have to be patient and go inside of the basic. Don't go and watch something that's difficult for your mind. Learn a little bit of theory. You can do your simulation. Okay, thank you for your time if you watch it to the end, of course. So I'll see you in my next tutorial.